on this computer. All right. So, welcome to the session on yarn. Today, we are going to go through the reasoning behind the yarn architecture, the new and the old, and the entire reasoning. Why do we need a distributed computing again? All right. So, but before I jump into our usual discussion, let me try to answer a few questions. A question from Rahela: what kind of proficiency is required in Linux in order for completing this training? Honestly, a very basic knowledge is sufficient. Okay, but it is up to you to go to a little bit more knowledge. And if I'm going beyond Linux basics at any point, I'll make sure that I'll explain to you in detail during the session itself. All right. So if I'm using a particular special command or I'm using a particular special syntax, I'll explain to you what does the syntax in the Linux command mean. Okay. But I would recommend that you should go through the assessment models that we have prepared, the one which I shared yesterday, and is also linked in session 1. All right. All right. There is. Okay, Krishna, I have fixed your account and it should be okay now. If any of you is facing the problem, it should be good enough. And you should just drop an email to support@nobigdata, support@nobigdata.com. A question from Rahela is that um, it's live access to the lab. Okay, so I'll explain. The LMS, which contains the videos and the content and the exercises, will be available to you lifelong. But the lab, since lab is a very constrained resource, the lab will be accessible to you only till the 3 months from the starting of the course, which means since our course was started on 14th of January, your lab will be accessible till 14th of February, 14th of April. Okay, so the course will be available to you till 14th of April. Okay. And yeah, so but the LMS will be available for lifelong. You can to extend, you can basically, there's a very small amount for which you can extend the CloudX Lab. You can extend it if you are planning to use later on. Okay. Okay. It's actually pretty small, like some $25 or $15. I'll have to check the pricing. Okay. So when your CloudX Lab is about to expire, so we generally delete the data after your expiry. Okay, but if you want to take a say break and then renew after a month or so, you want to keep your account inactive for say 1 month or so, keep us informed. All right. All right. Uh, Srini, I have changed your login in the LMS for No Big Data. Okay, are you around? Um, is your email ID this? something at Blue Shield CA? Is your account at blueshieldca.com? Okay, all right. Never mind. So I think he hasn't joined yet. Okay, great. So let's start with our next question. Question from Sunesh is, what is the difference between cloud computing and distributed computing? Okay. So cloud computing actually means the computing at somebody else's place. Okay. A computer at someone else's systems is called computer on cloud. It's as simple as that. Therefore, cloud computing means computing at some other server running somewhere in the cloud. Okay, it does not necessarily means distributed computing. While distributed computing is the branch of computing in which we learn how to distribute the work or how to build frameworks so that we can get the work done, get one work done utilizing many computers. All right, I hope that's clear to you. All right. There can be more than one computer or server in cloud computing as well. Okay, Sahida's question is, does HDFS have its own user when it is installed in Linux? Yes, there is a user called HDFS itself who basically is the super user for HDFS. Okay, so there is a particular user called HDFS who is the super user for the HDFS. And with that account only, we generally install HDFS. Okay, did I understand your question correctly, Sahida? All right, all right, great set of questions. Any other question at this point, or should we carry on? How can we run a client program in CloudX Lab? Okay, what do you mean by a client program? Okay, very good point. All right, so you copy this program into your console using a FileZilla. Okay, using FileZilla or SCP, you copy this program to CloudX Lab and there you can run it. All right, we are not exposing the HDFS to the outside world. What we have done is the port on which NameNode is listening to. Okay, so NameNode, as I explained in the session 1, NameNode or data node both are running as processes, and these processes listen at certain network port. Network port is a concept, is a software concept that we designate one number for each process, one number for each of the services or each of the sockets on which a process can listen to. Okay, and when you want to communicate, you communicate to that port. Okay, for example, when we communicate to a web server from the browser, we are talking generally on 80 port. Okay, so now coming back to it, so data node and name node both run on certain ports. We have blocked those ports from outside. That's why if you're running a client program on your desktop, you may not be able to connect to HDFS directly from your desktop. Okay. The reasoning behind that was to make it a little more secure. All right. If it's a jar file, then you don't have to recompile it, because in case of Java, if or any other similar language, you can code once and run it everywhere. All right. Just you have to check the version of Java for which you have compiled it. I think Java up to Java 7, it'll be okay. We are still using the Java 7. We have not upgraded it to Java 8. A question from Sunny is, why don't we have admin right? How can we see the actual physical location of the blocks? Okay, so that's an interesting question. Let me see if I can see it. Today, instead of using Web Console, I'm going to use a terminal. This is my terminal. Okay, so it's the same thing. Either I open the Web Console, or from here I do SSH. From here I do SSH. Okay, like this. For you, it will show password. For me, it is not, because I made it passwordless. Okay, by creating my public private keys. Okay, there is a concept called SSH key. Right now, I'm in the console. Okay, you can see all my files here. There's just too many files. Okay, now let me try. There's a question from Sunny that I'm trying to answer. It could be very useful to all. The question is, how can we see the physical location of the blocks? Okay, although it's not required, but let's try if we can have the access. So as we talked earlier, the data node stores data on the local machine, right? Which means this machine on which I'm standing right now, what is the name of the machine? This is E for me. If you see, this is E for me. I connected to e.cloudxlab. Okay, I said SSH Sandeep Giri 9034 e.cloudxlab. Okay, same thing when I do via browser, I also log in here. Okay, now question is that why don't we have admin right? Let's first try to access the data nodes. Right. So data node is running on this machine also, and data node is storing files and data on the local machine, right? Because data node would be running on many machines, and data node actually uses the hard disk of each machine, right? So let's take a look if data node has created something here. So there is a folder, you can see Hadoop. Okay, and let me see. Okay, so this is the place where it stores data. Okay, this is a place every data node on all machines would be storing data. All right, so here it says that this is this is some number it has done, and I think this is the name node. So for each name node, I think it's keeping a separate folder here in case it's scattering to multiple name nodes tomorrow in case of federation. That's why. Okay, so this is some kind of structure it's maintaining on every machine. This data node is maintaining on every machine so that every block can be saved here. Okay, so yes, it has created some subdirectories for keeping the blocks. Okay, and I'm just going into first subdirectory. Okay, right, so you can see that the blocks are stored here. Do you see? These are the blocks that are stored here. Okay, so it seems like this one is binary file, and to look into binary files and to extract strings out of it, you can generally use string command. PWD means yeah, you can see PWD. So I've gone into further and further. I'll just give you the location, so you can try a similar thing. Okay. All right. So you can see that this contains all the blocks here. So similarly, for other directories as well, it would have created some other folders. You can see that, and you can see grep blk in the line end. Okay, what was the name of the file? I see. There is .meta file. All right, let me just search for this particular line, .meta in the end. There are quite a few files, as you can see. And if I say wc, wow. So there are 2.6 lakh blocks. Okay, all right. It's a good question. Thank you, Sunny. Let me check what is the last updated file. To see the last updated file, you could say ls-l rt. T means sort the data, sort the files by t. And reverse order, show all the files and show the listing. Okay, so subdirectory 44 is something that could have our last file, right? Again, let me check who is the most recent file. Okay, let's see. Yes, looks like there is a file, and ouch, it is kind of okay. Let me try this one. All right, so there is some other file. Let me try this one. Okay, there's some other file. Good. So this way, these are the blocks. We are going to, mark it confidential so that nobody can see it. But for today, I think it's good that we have removed that protection. Okay. So now you can see that. Yeah, these are the binary files that are stored. Okay, and will be some file which are okay. Looks like all of these are okay. Never mind. So, all right. So this is where the blocks are stored. All right. If you want to see the fsck command that we ran yesterday, okay, it should show that for 179, right? This one, there should be a block ID, this one, right? So this is the block ID. And let's hope that we can find this somewhere. Okay. All right. So let me go up, keep going up. Yes. Grep looks like it's with some other name. All right, so this is the block. Okay. So we have found the block. I think 359. Yes, this is the one. And let's just see if we can see something inside it. Interesting. So how do I see? This was my file yesterday. You remember that? All right. Good. Everybody okay? So we kind of reverse engineered it, and we found the block which we had created yesterday. Uh, we found the block ID. Then we went through the local directory structure which data node has created, in which it's keeping the blocks, and we checked that it is there. Okay. Okay. So Kurt's question is there an alternative to console? Um, yes. Okay. So, but if your question is, can I get there without using the command line? Then my quick answer is no. But if you are asking what to use in case of in as alternative to web console, you can use either putty or you can use, if you are on Linux or Mac, you can use SSH. Yes, go ahead, Sunny. Okay. Sunny's question is, how can we know which node we are connected to? All right. So right now we are connected to e.cloudxlab. In replica placement policy, it'll try to copy block to current nodes. That's right. We are connected to, yes. So right now we are connected to this one. You see this one? This is what we are connected to. Okay. And if you take a look at our the fsck command we ran, right? So I quickly checked that one of the copy is capped on this machine. You see, 172.31.60.131, 179. You see this one? This is the first copy. Okay. So it's the same machine, and that's why we tried to go into data node. If no block was there on this machine, if there was no block on this machine, then we could have actually used some other. We will have to SSH into that machine and then do that. Okay, because it won't be on this data node. Great question. Great question. Let me create the notes file for today and update the notes over the week. All right. Let me also. Okay, let me just save it properly. 22 Jan. Okay, I'll try to make these available over the week. I'll put it on the LMS. Okay. A question from Kar. I'm confused between Ambari and Hugh. Okay. And yes, there is a good reason to be confused about Ambari and Hue. The reason is that both are competing, kind of competing products from Cloudera and Hortonworks. While Ambari started as pure installation system, whereby it'll provide a way to install Hortonworks, right? But then they also started providing interface to interact with other tools. Okay. For now, the way we are going to look at it, Ambari we are going to use generally for administration related activities. For example, installing Hortonworks package, installing Hortonworks Hadoop or HDP data platform, administer, meaning add services, restart services, shut down services, add more data nodes, and so on. Those kind of activities are generally done with Ambari if you are using Hortonworks data platform. With Hue is from Cloudera. The purpose of Hue is to be able to interact with all the services of Hadoop ecosystem. All right. A question from Krishna. Shall we see the data node path connecting to name node? That will be difficult actually. You mean to say the location at which name node is storing the metadata? Do you mean that? That'll be difficult right now. Okay, because I'm not sure if I have permission to SSH to name node, and I'll have to use some other admin account. Okay, but don't worry, it'll be in the similar structure. Okay, and yeah. All right. Kurt's question is when to use Ambari and when to use. I think this got answer. Is this notes available to? We will make it available. And okay, good, good. All right, all right. Very good set of questions. And what is the tool name? Same like Ambari from Cloudera. It's called Cloudera, Cloudera Manager or something. I have used it. It's a command line tool which helps you install the Cloudera on the cluster. Okay. Yes, you can. Yes, thank you, Kar. No, Hugh is not from Hortonworks. Hugh is from Cloudera. Okay, Ambari is from Hortonworks. Okay, and there is okay. You mean to say, is there some alternative from Hortonworks for Hue? Yes, they are trying to actually add features into Ambari, okay, into Ambari itself, so that it has all the features like interacting with Pig, interacting with Hive, all the features. So they're trying to compete with that way. Okay, but for us it's win-win, and we have tried to take the things from both the world, even though they did not they did not, they wanted to keep different kind of configurations so that people cannot install both of the things together, but we made sure that we install both because our objective is learning and not selling their products. Okay. And a question from Pradeep is Ambari will be mostly used by admin and admin? Mostly admin, yes. So developers generally just take a look at what are the components are installed via Ambari in a read-only fashion, and sometimes trying to figure out if name node is up or down, what's the IP address of name node, what's the IP address of, say, any other machine. So that information you can always gather about the network via Ambari. Okay, wonderful, wonderful set of questions. Uh, it's giving me a feeling that you are getting comfortable with the environment. Hue is used by developers and analysts and data scientists and data engineers in order to in order to interact with all kinds of services. Okay, people who are not very comfortable talking to via console, who are not comfortable with Linux, they generally find it easier to use Hue. Okay, a question is our homework programming language Python or Java? We are going to stick to Scala. Okay, I'm going to take you through a quick ride with Scala and then we will move on with Scala. Okay, so first we will cover the basics of Hadoop. We'll try to cut down on the parts which are only for Hadoop, and we'll move most of the content towards the Spark. Okay, most of the time we'll try to manage towards Spark. Okay, good. All right, great. Let's move on. Right. All right. No, actually, great. So let's talk about another large component of Hadoop called Yarn. Yet another resource negotiator, because it negotiates resources amongst many machines. Okay, so we're going to talk about its architecture previously and now, and why do we need it? All right, before that, let's try to answer a very simple question. Imagine Imagine that you have a million profile pics. Imagine you work with Amazon or say some company which has lots of profile pics of people. And they need to be resized to fit a certain size, right? And as per your back of envelope calculation, it takes around 20 milliseconds to read from the disk, to read a pic, average sized pic from the disk, and 5 milliseconds to resize it. Okay, although we should also talk about saving it back, but let's not talk about it. That will further make it complicated. Okay, so so it takes around 20 milliseconds to read the pic from the disk and 5 milliseconds to resize it. Okay, and you have say average computer 1 gigahertz, only single core, and 1 GB RAM. Okay, so how much do you think it'll how much time do you think? Okay, so for 1 million profile pics, how much time would it take to finish? For each of these 1 million profile pics, we need to first read from the disk and then resize that. Reading takes 20 milliseconds and Resizing takes 5 milliseconds. Yes, anybody? Sunny says 6 hours. Okay, it'll be great if you could, show your calculation as well. Yes. Anybody else? So when you read this, each of these pics, on an average, the time consumed is 20 milliseconds, and to actually resize, it takes only 5 milliseconds. Okay. So, okay. So 1 million into 25 milliseconds. Okay. That's right, Sunesh. That's right. And that comes out to be how many hours, Sunesh? And divide by 1000 as well. So it's 25,000 divided by 3600, okay, which would come out to be how much? Okay, let me try to show you. Okay, although it looks a little slower to do that. So we had 25 milliseconds, right? Into, so it'll be 25 milliseconds into 1000 divided by 3600, right? Around 7 hours. Okay, but we are wrong. We are wrong. Let me explain why we are wrong. This is a very important point. This calculation is wrong. Why? Because on a larger scale, if you have a million pics, right? If you have a million pics, the time taken to resizing would be parallel to reading another pic. Why? Because while we are resizing the previous pic, so here we are reading the pic and then resizing it, then reading another one, resizing it, reading another one, resizing it. So the resizing is happening parallel to reading another pic. Okay, it's a very important aspect, and this is something which I did at Amazon while building this uh, image, the tool that displays Amazon.com's product image, that image selection. So that time we had to do a computation that how much time would it take to finish selecting all the images of all the products at Amazon, and how to do it faster. That time, so we did exactly this. So the common problem which I found with most of the engineer in my team as well at Amazon, that we could not do the computation when it came to parallel, when it came to multi-threading. Okay, let me take a step back. So when you have this kind of assignment, you think about what are the resources are we going to use. So while we read a pic from the disk, it's the disk speed which is taking the maximum time. CPU is free. CPU is not doing much at that time. But while resizing the picture takes a lot of effort. You have to go pixel by pixel into the memory and then move it, right? So resizing consumes CPU, but does not impact the disk speed. Therefore, resizing and reading the pic could happen same time. It's just that it can't happen on the same file. Okay, so the way what we did was we created two threads. One thread is a way of segregating the work. or we created two processes. One was reading the pic into the memory, other was resizing the loaded pic. Okay. Therefore, the time that got consumed in resizing is not a bottleneck. Okay. So effectively, on a large scale, it is only reading from the disk that took maximum time, not resizing. Okay. So we can actually comfortably say that it takes 20 milliseconds, 20 milliseconds to to resize of to completely read and resize a particular file. Okay, so it'll be 20 million milliseconds divided by 20 million milliseconds is the time it'll take to finish this. Okay, all right, a question from RS. There could be a few more threads for even reading the pics in the parallel, right? It's a very good question, and yes, that was the second thing I found that we need to understand. So even if at this point, if we try to read multiple pics at the same time, it's the same hardware. It is the same hardware. It's going to get worse. Therefore, you should not try to read multiple files at the same time. So you cannot have multiple threads to read the data. Okay, you should not have multiple threads to read the data. If you try to read something else in parallel, it's going to impact this speed. Do I make sense to you? No? All right. Yes, it is disk's limitation. So what RS has said, it could have been a valid solution if we were using something like solid state drive. Okay, solid state drive can provide parallel reading, but again, when these disks provide reading in parallel, it generally impacts reading of one file. Okay, all right. Okay, let me explain once more. Okay, so to resize the pic, we have to do two things. One, first we have to read the data into the memory so that our processor can process it, right? And the second is processor need to process it, resize it. So reading from the disk consumes makes this hardware. There are two hardwares in here. One, the, the reading from the disk, and other is the memory. Other is the CPU, sorry. Other is the CPU, and memory connects the two. So, well, so there are two things you could do in parallel on this computer. One, reading the file, and other is resizing it. Okay, so the work gets divided, and it is reading the data, which is the bottleneck, because that one is taking 20 milliseconds and the resizing is taking 5 milliseconds. Therefore, we can simply ignore the time taken to resize, because if you see at 0th second we started reading the pic 1, and at 20 seconds we finished reading pic 1, and then from 20 seconds to 40 seconds we actually finished two things. One, resizing pick 1 and reading pick 2. And at 60 seconds, we finished reading pick 3 and resizing pick 2 and pick 1. Good? So basically, it's only because the more time is being taken by reading the data from the disk. Therefore, that's the only thing we can count. Okay? All right. I hope the idea is very clear to you why we are ignoring resizing. Yes. Yes, it's because single thread process is reading in sequence. And we want to read in sequence because this hard disk, if multi-threads try to read from the hard disk, it actually slows down everything because will be jumping from one place to another continuously and leading to maybe damage of the disk or leading to a very bad performance. Therefore, it's always advisable to read one file at a time. Okay, so yeah. A question from IS, we can do the data reads in parallel as data is stored in different data nodes. So that's in the case of HDFS. Right now, we are talking about without Hadoop. All right. So yes, you are just a tad ahead of us. Okay. And Mohit's question is, I see that ongoing presentation deck is slightly different from what is uploaded currently. Actually, I worked on this deck last week, so I'm trying to improve it. And as in general, we keep on improving as we go ahead. Therefore, it will take me maybe this week to update it on the in the LMS. Okay. All right. So that means it's not 7 hours, it's around 5.6 hours. Okay, because we're not counting, we are taking 20 milliseconds instead of 25 milliseconds. Everybody okay with this? Yes, that's my next question. Okay, so Kurt's question is, what if cloud is used? Okay, so if you're using cloud and you're using only one computer there, then it'll be the same answer. If you are using distributed computing, the answer will be different. Okay, so now let's try to do this. Now, let me ask you this. Can we improve it if we buy quad core computer, meaning a computer that is having 4 cores? Was the CPU bottleneck in our previous discussion? Who consumed those 20 milliseconds? CPU or, or reading from the disk? Was the CPU bottleneck? So, right, right. So basically, yes. So basically, the answer is no. Even if we have 4 cores, right? No matter what you do, these 4 cores will be sitting idle, waiting for data to read from the disk and then process. Yes, there won't be any pick to resize because resizing will finish very quickly. Instead of 5 milliseconds, if you divide that to 4 computers, it'll become like 5 images can be processed parallelly. But reading will still be the same disk. Okay? Reading is still happening from the same disk. Therefore, We should always understand that what is our bottleneck. And this is something I found missing even in senior engineers, that when we think about making a process faster, making a computing faster, okay, we always think of in terms of CPU, in terms of RAM, but we don't think of think of computing in terms of reading from the disk or reading from the network. Okay, so answer is no. No matter what we won't be able to improve it. All right, so now what next? What can we do in order to make it faster? This is it wrong or right? Yeah, I think this is right. Okay, yes, everybody is with me till this. Both the answers to the questions, everybody is agreeing. Okay, all right. Now, so how can we, if we cannot make it faster by improving the machine to quad core, what can we do? What can we do in order to make it faster? One quick answer would be to put a faster hard drive. Okay. Second quick answer would be to use maybe solid state hard drive. Third possible answer would be to Third possible answer would be to have multiple hard drives in the same computer. Fourth answer would be to use many computers. Okay, and that one is more general and better solution. That one is more general and better solution. Why? Number one, that would divide the disk reads, as well as that will divide the ability to read from the disk to many computers instead of one. Secondly, the data that we are talking about, 1 million profile pics, that could have been itself a challenge to store. And therefore, it would be better if we put it in the network, in the distributed file system like HDFS. So most likely, if you are dealing with humongous data, that's already in HDFS. Okay. Therefore, we need a framework on top of HDFS which can do the computing parallelly, which can do the resizing parallelly on machines which contain our data blocks. Yes? All right. So for that purpose, the first design of MapReduce is as follows. MapReduce was designed for this purpose. And the MapReduce 1.0, this is the design of MapReduce 1.0. The design was the design was the design was such that similar to HDFS, there is a job tracker and there are many task trackers. All these task trackers are nearer to the data node. And generally, machines that contain the data node, we install task tracker there. So again, task tracker and job tracker, both are network processes. So we have job tracker and task tracker Job tracker is like the supervisor, the go-to guy, okay, to who you give the order. And internally, job tracker delegates the work to many task trackers. These task trackers, when they finish the work, they report back to job tracker saying, we are all done. And job tracker gives us back the completed task and taking the full credit for it. All right. So basically, job tracker is like the network, like the supervisor of a, a, a workshop. In a workshop, if there are many workers, there's generally a supervisor who you go and say that get my work done. He'll say that okay, I'll get work done. Internally, it'll divide the work into welding, finishing, carpentry, and this and that, and then get the entire thing assembled and give it to back to you. That's job tracker. While individual worker, somebody who is doing the welding, carpentry work, those are task trackers. Okay, does it make sense to you? All right. Okay. All right. Let me try to answer those. First question is, so Rahila, your question is answered, right? Okay. Another question is from Mohit. Why would having multiple disks in a computer not work? For example, that we took. Okay. Uh, okay. That's what you mean? Yes. So yes, that's why I was saying that there could be multiple solutions. One, buying a better hard disk. Second, buying a faster hard disk. Like there are many RPM hard disks available, like those production quality, but they will make a big hole in your pocket. Next is buying multiple hard disk connecting to the same machine. So yes, that would work, but that's not a scalable solution, right? That's not a scalable solution. What would happen is you have a limited memory. And when all these machines are trying to read pick into the memory, okay, if you have like 4 hard disks, then 4 images are being loaded into the memory simultaneously. The RAM will be the bottleneck afterwards. Okay. Okay. Plus, it's on the same data bus. That could again be the bottleneck. Thank you, Reed. Yes, it's on the same data bus. That's another bottleneck. All right. Very good question. A question from Manu. How we will get those two trackers along with Hadoop? Okay, so these are all part of Hadoop. So these were part of MapReduce 1.0. You had admin node, and then you have many data nodes, and so on. Okay, so these all of these trackers are installed as a programs running as a services on each machines. They are basically Java programs. All of these data node, task trackers, name node, or job tracker, all of these are task trackers. Sorry, are Java processes. A question from Rahela. Job tracker and name node should be on the same server. Okay, very good point. Although this diagram here makes it look like that job tracker and name node are like close brothers. They need to be on the same machine. The answer is no, they don't need to be. Just that job tracker must know where is name node, right? Where is name node, so that it can talk to the name node and and you know find out where are these images located on which data nodes, and then accordingly it will give the task to only those task trackers which are closer to your data. Okay, this is called data locality. So job tracker, when it takes the work from you, let's say image processing work that we talked about, the image processing work that we talked about, job tracker will take that work from you, then find out where are these images located. Okay, it'll ask this name node, can you give us the list of all the data node containing these images? And then we'll find out on which all machines, okay, on which all uh, machines it should execute the work such that the work gets executed. The resizing logic should run only on those task trackers which are nearer to the actual blocks of your data. Okay, makes sense to you? So that data does not need to be transferred from one data node to another task tracker, because if they are located on the same machine, there's no network communication, and reading from the disk and then resizing becomes very easy. Otherwise, if data is here and resizing logic is here, the data will have to go through the network boundary to another machine, and it will take time. Therefore, the another role of MapReduce was to make sure that the data get processed on the same node where it's located. Okay? In other words, we send program to the data. Job tracker, when we submit a job, we are handing over the logic to the job tracker saying, can you get it done near to my data? And here is my data folder. Here is the name of my data folder, and you know the name node, and this is my program that you need to run, a program in the form of maybe a Java compiled code. We hand over that to job tracker and say, can you get it done nearer to this particular data? And then job tracker will talk to the name node, find out which are the data nodes nearer to your data, nearer to the files in that folder that you are handed over mm, to the job tracker, and then it'll go there and get it executed, your program nearer to the data on every file. Okay, it'll execute your program on every file. Yes. All right, so this is MapReduce. Sudhakar's point is, what if task tracker gets corrupted? In case task tracker goes down, task trackers are stateless. Task trackers are machines that run the logic and then forget what they did just now. Okay, so task trackers does not, for them, it's like it doesn't matter what they did a few minutes back. They get back to another work. Now, question is, what if task tracker gets corrupted? It doesn't matter. So in case one of the task tracker just goes down or does not respond, so job tracker keeps on getting pings from all the task tracker. In case any of the task tracker does not give the response back to the job tracker after a certain point, it just assumes the task tracker to be dead and does not wait for the response from task tracker and assigns the same work to some other task tracker. Now your question would be, what happened to the data locality then? Right? There was a file that that needed to be processed on the task tracker, and the task tracker went down. Now job tracker will try to find another task tracker having the same data, having those same blocks, and get it executed there. because every block has copies, right? Therefore, it is possible to find another task tracker nearer to the data. So, so all these task trackers would be working in parallel. If you have 5,000 machines and the same work which was taking like if you have say 5 machines, let's not talk about 5,000. If you have 5 machines, same work what we just did in 5 hours, it'll take only 1 hour to finish. Okay, it'll take only 1 hour because the work gets divided parallelly to all the machines and you get the response. Okay, all right. So yes. So Sudhakar's question is, yes, thank you, Mahmood. I think you gave the answer. Yes, Sudhakar's question is, what is the allowed time for task tracker to complete the work? What is the allowed time? So there is, I mean, you have a timeout period, something like 5 minutes or 10 minutes. Okay, if any of the task tracker does not finish the work there, job tracker generally kills the task tracker, that particular task, and move on. Okay, that you can configure. Then is it not computationally intensive to always track the task nearer to the data? Okay, so it's not very, very difficult. So when you submit the job to the task tracker, it basically queries name node, finds out the IP addresses of all the name nodes, all the all the data nodes for those files, so that file, and then finding those task trackers nearer to those machines is not actually very difficult. It's basically a very simple algorithm to find it out. Okay, the whole network is represented as a tree, and finding it out in the tree is very quick. Okay, and, in another way, basically the work happens on the basis of IP address, and finding IP address from the from the file is straightforward, and then based on the IP address, finding task trackers on those IP address is very straightforward. Okay. Uh, a question is, but recomputation happen only if initial task tracker fails. So the entire whatever task tracker was doing, whether it was halfway or it has completed 90% of the work, it doesn't matter to the job tracker because it will be difficult to resume the work. Okay. Therefore, if task tracker fails at any point, the entire work of that particular task tracker is assigned to somebody else. Okay, it's not really possible to resume the work on any other machine. A question from Kar, is this the latest MapReduce version we are discussing? No, this is MapReduce 1.0. Okay, all right. Sahida's question is, when a job is submitted, is there a specific algorithm it uses to assign the task to task taker? So yeah, so basically, I mean, I'm not sure about exact algorithm which it uses. Yeah. It basically represents the network as a tree and finds the distance between the nodes. And Pradeep's question is like MapR. Spark also does the same job of having job tracker and task tracker. So no, we will discuss this architecture. All right, we'll discuss this Spark's architecture. Now Sudhakar's question is, will the data node is absolute if task tracker is getting killed all the time? No. If task tracker, if let's say task tracker is not completing the work, the data node has its own existence. Okay, data node is a part of HDFS, and for data node it doesn't matter. Okay, because data node gets used by many other processes than only task tracker. We'll talk about latest version. Okay, so now in this model, when we talked about handing over the work When we talked about handing over the work to job tracker, when we say get my work done, there is a specific way of handing over the work. And the way it worked was we had to write two functions, map and reduce. And then in the map, all the logic that needs to be done on the same machine where the data is existing, we'll write all that logic. And in case we need to combine the data from all the nodes after processing, we use the reduce phase. So we used to convert our problem into map reduce in order to get work done using this version of map reduce. There was only one way of distributed computing, map reduce. Map reduce was the only way of expressing our need. In case of MapReduce 1.0, there was both the work of dividing the work on both the jobs of dividing the work on many machines, and then executing the logic of MapReduce and sorting was happening in the same software. It was the same software which was doing both the things. So it was a little too clumsy to have both the logic of managing the resources, assigning the work, as well as running maps and reduces. And the that's where the idea of breaking down this MapReduce 1.0 into MapReduce and Yarn happened. MapReduce 2.0 and Yarn were basically offspring of the single component, broken. So single component of MapReduce 1.0 was broken into two parts, okay, called MapReduce 2.0 and Yarn. MapReduce 2.0 and Yarn basically are refactoring or factorization of MapReduce. Okay, when you break down this code into two parts, that's what it was. Sudhakar's question is, will the data node be obsolete if task tracker? Okay, I have answered that question. Kerr is saying, what is the latest MapReduce version? Yeah, so this is Hadoop 2.x. As of now, we are using Hadoop 2.7. But since the major version, which is 2, is same, the design is same. Okay? So you can see that the MapReduce was broken into two parts, MapReduce, MapReduce and Yarn. Now, why was it done? Why was it done? Okay, why was it done? So that earlier, I mean, if you look at the MapReduce code, we will discuss MapReduce code. It was too restrictive. Any kind of work that you need to get done, you always have to express it in terms of maps and reduces. If you have many phases of map reduces, you have to write multiple programs. So creating map reduce programs was hard for every. Second, the kind of problems we need sometime is that keep my program running forever. That was not possible using MapReduce 1.0, right? And the other challenges, there were many other challenges with MapReduce, so I'll talk about it. So support for workloads other than MapReduce, right? Scalability, right? Scalability was another important criteria. Scalability as in, if we need to add more nodes, it should be easier. So those kind of features were added in Yarn. Okay, so MapReduce 1.0 did not have Yarn. Yarn was basically part of MapReduce 1.0 itself. Okay, so the important part what this rewriting of MapReduce did, very important part, that it kept it very compatible. It kept it very compatible to the older MapReduce. Meaning, those people who have written their code for previous MapReduce, they did not have any, They did not have to make any kind of changes to their MapReduce. It just ran out of the box. They just had to recompile it. Okay. It also improved cluster utilization. Why? Because all kinds of frameworks started coming. It made it possible for people to write frameworks which are competitor to MapReduce. Okay, so not only MapReduce was the way to express your logic, or not only okay, not only the way of expressing this clumsy way of logic, like maps and reduce, is not clumsy as in it was hard to express it. Okay, I'll show you my previous session's problem. Those were hard to solve using MapReduce. Okay, and therefore there was a lot of, because of this change, because of this breaking down MapReduce and Yarn took care of the cluster resource manager. Okay, cluster resource manager, what is near, what resources are up, what resources are down, which one is busy, which one is free, and who can I get the work done. That kind of work was absorbed by Yarn. Okay, and this is where it became open to more and more ideas and more kind of workloads, and thereby leading to this humongous revolution, whereby all kinds of newer frameworks came up. And because of this, today we have Spark. Because of this change, being open to the new workloads, okay, it was possible to run Spark out of the box without installing on Hadoop. Okay, Yarn made it possible that you don't need to install something on the cluster and run that on the cluster. Okay, and that's why we are able to run around five different versions of Spark parallelly. If there's a new version, I just downloaded my home folder and run it. While running, it goes and talks to Yarn and get it executed everywhere. So a question from Manu. So in 1.0, MapReduce programs responsibility to find resources. It was the MapReduce framework which did the entire work. It wasn't the duty of the developer or to write such code. Okay. It was the MapReduce 1.0's framework itself, the single piece of code. Yes, Yarn is becoming single point of failure. That's right. That's why there are backup mechanisms and there are ways to protect it. Okay. In the same way that name node we have protected earlier, Yarn can also be protected in the same way. All right. All right. So the task tracker became node manager and job tracker became resource manager, application master, timeline server. The slot under which map function or reduce function would get executed earlier in MapReduce 1.0 is now called container in Yarn. We will talk about this design in detail. Okay. One more thing was when we hear this word called batch oriented, okay, what does it mean? And what is not batch oriented? Okay. So what does it mean by batch oriented? Batch oriented means something that you submit, it gets done, and that's it. That's batch. Sometimes you may want your work to keep running for years, right? Let's say what you want to do is you want to run a web server, or you want to run an analytics engine which continuously gets data from, let's say, from your main web server or web server logs, and continuously displays a graph. Now, this kind of servers, this kind of systems are not batch oriented because they run forever. They run as long as there is input data, and they wait if there is no input data. Okay. A question is, can we bypass MapReduce to get our job done? Now in Yarn we can. All right, let's talk about the architecture of Yarn. Okay, it's very important because we are going to use this architecture while understanding Spark as well. Okay, so this is Yarn. You see this whole uh, the diagrams. So task tracker, job tracker is broken down into these many components. So the first important component is the client. Client is the one with which you are going to submit the work to the resource manager. That's the client. That's the program which will be used to translate your need to something that you submit to resource manager. Now, this resource manager would basically be the first point of contact. You submit your work to resource manager, it'll consult the node managers. So you have 3 nodes here. These 3 nodes are being manned or owned by node manager. Node manager is the single point of contact when it comes to executing something on node manager. Okay, on this node, if resource manager wants to get something done, it will consult node manager. Node manager takes the responsibility of managing how much memory is being consumed, how much memory is free, how many contain it, and it will gets the work done inside the containers. Containers are kind of virtual machines in which the work is being run. Okay, containers are the way the work gets done. All right. Now, till this point, everything is okay. Resource manager takes care of central work. Node manager takes care of each individual node. It executes the work in the form of containers. Okay. Now, there is one more idea called application master. Recall that Yarn was designed to be very flexible and support all kinds of workloads. Therefore, Yarn came up with an idea called application master. Application master is the first process that gets executed. And after application master gets executed and run, then application master takes over and gets the rest of the work done over the cluster. I'll try to explain this with a very good analogy. Okay, so a good analogy is this. Okay, so let me just go ahead here. A quick overview. Okay, just be with me for a minute. So client submits the application. Resource manager launches the application master in one of the containers. So application master is something that gets executed. Okay, I'll come back to this one. First, let me describe it in this way. This will be easier to describe. Okay, for a moment, let's think about the whole yarn as a country. Okay, the whole yarn as a country. Okay, what is yarn? Yarn is composed of these kind of machines, and you have basically many machines. One of that machines is designated as resource manager, while the rest of the machines are designated as node manager. Okay, right? So think of each machine to be like a state. Okay, and the whole the diagram that you see here is yarn. Who think of yarn as the country, and resource manager to be like a president of the country, and the client to be somebody who wants to establish their offices and get their work done. For example, Shell, a petrol company, and Microsoft, right? If you think about these kind of clients, they have their different kind of works. Okay, so the way it happens is Microsoft goes to the president, says that hey, we want to set up our office across the United States, and president says let me talk to the governors of each state, and after negotiating with governors, president gives a go ahead, and the head office of Microsoft is decided. Okay, so they create a head office. Remember that head office is also an office. Okay, so it runs inside a container. Okay, it runs inside an office, and these offices abide by the constraint imposed by every machine, every state policies, right? So so the head office is established, and afterwards it's not Microsoft from the external world who communicates further. It's this head office which basically gets rest of the offices set up in various states. Now this head office asks president again, can you get more offices in different states? Okay, in California, in here, in there, and so on, right? So basically the state offices talk to the head office talks to the resource manager afterwards to get more offices across the country in other states, and those offices are also established, and once the work is done they might close down the entire offices, or they might keep running forever. Okay, is this analogy clear to everyone? Yes. Okay. Okay, so you can always think of Hadoop MapReduce 1.0 to be communist regime where there was only one kind of offices that could be set up, which is government's offices and not private offices. And here, this architecture supports setting up all different kind of offices, right? So in MapReduce 1.0, the only work that could get done, the only workload that could be supported was MapReduce. Here, the kind of work that is supported is all kinds of workload. Okay, it's similar to communist and the capitalist kind of society. Okay, so I hope this is clear to everyone. Now I'm going back to our, the diagram. So client submits the request to resource manager and says that, hey, this is what I want to get done. I want head office. Then the head office gets established in one of the containers. Containers is the kind of, the virtual machine which ensures that this office or this particular the application does not violate does not violate the terms, meaning it should not go beyond certain memory, should not consume more than this much CPU, and so on. Okay, so container is something that enforces all kinds of discipline. Okay, and application master registers with resource manager, and then the client keeps on monitoring their application master, meaning Microsoft keeps on monitoring their head office. Okay, and application master asks for containers. Okay, meaning head office asks for more resources. Resource manager allocates the containers, okay, meaning more offices if needed. And then node manager launches applications inside these containers to get the actual work done. Node manager talks back to the resource manager about the resource usages, okay, meaning each node manager informs the resource manager about this status, and the client keeps on communicating to the application master, meaning the head office, to monitor the state. Once the work is completed, application master deregisters itself from the resource manager and shuts down. All right. So I hope this architecture is clear to everyone. It's a it's a very broad level architecture, but this should be good enough to all of you. A question from Jackarone is a question from Jian Kun. Uh, is Miso similar to Yarn? Why do people choose on over the other? Okay, so Mesos is basically a little lighter version, is a contender of Yarn, and I'm not sure what is their architecture. Okay, I would love to go through it. Let me make note of it. Mesos is basically a newer contender to Yarn. Okay, so why do people choose one over the other? Basically, what kind of application can we execute? What is our size of, so the various criterias that are being used for the work that you gets done. Okay, uh, sorry, the criteria of choosing one over another is how many users do you want to execute, do you want to be using your system. Okay, if you have too many users, mesos could be a mesos could be, let me check that part. As far as I remember, mesos was a good solution if you have too few users or something like that. Yeah. Okay, so one is number of users. Okay, the kind of workload it can execute. Okay, and how many, what is their, yeah, the basically what I understand between people choosing mesos versus yarn is number of users and what kind of workloads that can be executed. Okay, a question from Mohit: what arrows between containers and application master signifies is? The arrow signifies that application master talks to the containers, and containers basically register itself to the application master, and there is a clear communication between application master and the containers. So application master orders to the containers. All right, good question, very good question, Mohit and Jian Khan. All right, I hope the architecture is clear to all of you. Please feel free to ask. Question from Kar: is there any limitation with yarn? Okay, so yarn basically, how should I say, people find it little too restrictive at times, but so far it has been accepted very well by the industry. Okay, some even complain that it is little slower, but so far yarn has been the most flexible out of all. A question from Sudhakar: is yarn installed on all the machines of data nodes? So it's the node manager, it's the process called node manager, which is installed on all the data nodes. Okay. A question from Mohit. Why does app master talk to container of a different node as we see here? Because it's a head office and there's the state offices. Head office is responsible for the entire operations. Okay, so the work that client wanted to get done is basically taken by this head office, and that's why head office communicates to all the containers. Okay, so this head office is more like a Trojan horse which runs, and or that's like a little derogatory, but application master is the one which basically gets the entire work done. Whole logic, let's say there could be one application master for MapReduce, other application master for Spark. The entire logic of sorting in MapReduce and all of that logic, the coordinating between all the machines, that one is taken care by the application master. Run mapper here, run mapper there. Once mappers are done, collect the data, and then run the reducer. That kind of work is done, that logic is done by application master. Okay, so it's the head office who is responsible for taking care of the entire responsibility of getting the work done on behalf of the client. A very good question. Is it possible sharing the work process between node manager without resource manager allocation? Is it possible sharing the work process in between node manager, okay, without resource manager allocation? If you're going through Yarn, answer is no. Okay, basically, but if you establish app master once, then actually you can get work done between the container, talk to the multiple containers. For example, here this application master is talking to one container here, two container here, meaning head office is here but two offices, two offices in say, how should I say, um, one office in say New York and two offices in say, what is the state, Redmond, okay, for Microsoft. So you have three offices in all. Okay, so the work is getting done between these three without actually going through all the time via resource manager. Okay, does that answer your question, Srini? Yes, Pradeep. Um, okay, let me go through one more question. Rahila's point is, it's like police headquarters in application master and sub-police offices in various areas are the containers. Yes, you can take that analogy as well. Okay, so the idea is whether it's security agency, police agency, or Microsoft or Shell, Yarn guys figure out that they could build a very generic architecture that could let all kinds of agencies or organizations run through the same states, okay, and be able to get their work done. Yes, that's a good analogy, by the way, Rahila. A question from Kerr: where security is handled? Client is requesting for data that they are not authorized. Very good question, Kar. So yes, that's where this component called container. Inside container, things get done. Whether it's application master or any other application work that's getting done, it happens inside the boundaries of container. They, they basically go through the container. Container ensures that security. Container, because all of these programs are external, that's getting executed on all the nodes. So container enforces that security. Okay. All right. The work done by app master and container executes the logic of any kind of logic, whether it's app or app master. Okay. Inside container, here is the app that's getting executed. Here the app master, head office, or whether it's a head office or it's a normal office, the sub office. All of these are offices, and offices abide by the constraint imposed by the government. Okay. Similarly here, container executes app master as well as application logic on every node, or in a single node. It ensures the security and safety. I hope that explains, Pradeep. A question from Ravi. One another analogy could be car manufacturing company having to deal with several component manufacturers divisions in different locations, and there would be a coordinating office that accomplishes the whole assembly of the car as a whole. Yes, yes. The idea of this coordinating office is important because it lets the work of various different kind of coordinating agency to be done. Okay, not only one kind of workload. All right. So the biggest difference between MapReduce 1 and Yarn architecture was the idea of app master. Okay, idea of app master, because in Yarn you don't have to install, say, Spark. A newer version of Spark has come, but you don't have to. We never had to install the whole Spark again on all the nodes. We just, we did not have to tell Hadoop that we are installing Spark on all the machines. We just have to download in our home directory and start using it. It's just that instead of only downloading, we made it shareable and available to all the people, and they could use it. So we did not. So why? Because when we submit the job, the entire Spark brain actually get installed in App Master. And when the work is done, that's delocated. Okay, you might wonder that it would be like too much of a headache to set up the App Master every time again. Why are we doing this? The interesting part is it's not that big a headache. It hardly takes like 30 seconds. Okay, but if you want to avoid it, you can always keep a particular program running forever, and you don't have to keep starting app master again and again. All right. Can I have multiple app master in one node manager? You can have multiple app master in one node manager, but there could be only one app master, one app per application. Okay, I'll talk about this. You will get the idea. Okay. A question from Kar: is Kerberos or LDAP authentication for clients possible? Yes, Kerberos is supported. Very good question, Kar. Mohsin's question is: there are so many distributed components of Yarn, SDFS, etc. Many failure point. Is there a way to monitor process ID or dashboard to see and debug flow for given task? All right, all right. So basically, the App Master provides an interface in this case. Okay, so so App Master, it is the duty of App Master to provide you an interface to debug the situation. In case of MapReduce, it gives you a URL to monitor how many maps and reduces are executed. In case of Spark, they provide their own interface. We will see those interfaces to debug. It's the same URL that is there. It's just the interface switches when you run MapReduce or you run Spark. Okay, you get a feedback as a URL for monitoring your process. Okay, per task. George's question is there a security policy or what is this called? Yeah. So yeah, security policy, as I told, it is basically Kerberos that is supported. I'm not sure about LDAP. Okay, so basically, it's not basic in the when we talk about security, right? It's Kerberos or NTLM. LDAP is a directory access protocol. Okay, so it is the Kerberos which is important, not here, since the design of these architecture is mostly like Unix. So the SSO is the Unix one, which is Kerberos, which is accepted everywhere, is has been supported by them, not the NTLM. Okay, so that's one of the reasons, Kar. Okay, so this is as per my knowledge. Maybe now they have started supporting, and I may not be updated. Okay, so yes, all right. Now there was a question about, yeah. So that was application lifespan. I'll talk about requests. Okay, are we having? All right, I think we are already running beyond our time. Okay, so a question was, let's take a break for 10 minutes, back by 9:57 p.m. IST. Okay, I'm not sure about other time zones. Okay, Okay, so I'm back. Should we start now? Are you able to hear me clearly and see my screen clearly? Wonderful. Wonderful. All right. So before the break, we were talking about yarn. We talked about how does yarn work. We have node managers, resource managers. Resource managers are central agency, while node managers take care of individual node, and node manager execute things inside the container. Okay, just that first container that get executed is the application master. An application master further behaves on the behalf of the client. Okay, so application master contains the logic which knows how to coordinate between other containers and get the work done. All right. Now, a common question is when we say that we are requesting something from resource manager, if you see in the design, client is requesting something from resource manager, application master is also submitting the request. You see, you see these dashes? That means it's re a request for resources. Okay, so what does it mean by request for resource? What does this request contain? Okay, so this request is like resource requisition request in general. And here, whosoever is requesting, they can specify how many containers they want, the memory of each container, and total number of CPU that they want. Okay, number of containers, memory of each containers, and the CPU, along with locality constraint saying, give me only the containers which are nearer to this particular data. Those are locality constraints, either upfront or as you go. Okay, either upfront means either give me all the containers now or saying that we will ask for more containers later. Okay, that's resource request. All right. Now, for how long does the application run? That's application lifespan. The application lifespan could vary very dramatically. It could be very small or it could be very long. Okay. So in general, lifespan is categorized into three categories. Okay, three kinds of jobs are there in the world. One is most simple one is one per user. As in when people submit a job, a new application master is created, and that's it. That's a case of MapReduce, right? Sometimes what you want is you want to use one application master for a little longer, meaning you want the job to be running for many kind of works. Okay, we want different kind of work to be run. We want a particular application to be running for very long and doing things for us very long. In that case, we call it for a one application per workflow or user session. Like for example, in case of Spark. Okay, or you can always think when you launch Python, for example, I'll show you how does it look. So you see here, this is my console. It's long running. This shell has been opened for some time. It's waiting for me to type the command. That means it's a long running application. Okay, so not long running, it's called one application per workflow. Okay, so in the similar way, the Spark also, when you start a Spark interactive shell, it will start application master, and that application master will remain as long as that you keep that interactive shell open. Okay. The third one is long running application, such as HBase. HBase keeps running forever. It doesn't shut down. Okay. HBase keeps running forever because it's a database. A database runs forever. Those are called long running application. Okay. So those are called long running applications. Apache Slider and Impala are another example of long running application. A question from Kerr. I'm trying to understand your CloudX Lab architecture. How from Hue we are directly connecting to HDFS through the console? How from Hue we are directly connecting to HDFS through console? No, when we are using Hue, we are not using console. Okay. Hue, by default, if you install Hue, it will by default talk to HDFS on your behalf. Okay. And when we are accessing HDFS, we never talk to Yarn at all. Okay. We never talk to Yarn at all because HDFS is totally independent of everything else. Okay. Here, per user job or per user session job, okay, are two different things. In case of MapReduce, it is not possible to keep the work waiting for the user input, right? In case of MapReduce, it's not possible for the work waiting for the user input. In the second one, it's possible for the job to wait for the user input. Make sense? Right? So when we open a Spark shell is like our bash shell, the one which we have interactive console. It'll keep on waiting for like hours, okay, for your input. And then if you basically analyze data, think about what next command to type, and then you can type again, and then it'll get that work done and so on. So that's per user session. All right. Kar, did it make sense to you? So I would love to understand your questions in stepwise fashion. So how from Hue we are directly connecting to HDFS through the console. So Hue itself has a client under the hood. So when we are requesting Hue from the browser, it is under the hood making the call to the command Hadoop FS and doing the things on your behalf. Okay, that's how Hue is working. Does the request go through Yarn first? No, it doesn't go through Yarn first. Okay. Hue is a server. Hue is a server. Hue is not running on Yarn. Okay. Hue, Ambari, they are not running on Yarn. They are independent component. Okay. Did they make sense to you, Kar? Um, what kind of architecture are we looking here for? It's the same ecosystem. It's the same Hadoop ecosystem. We haven't, changed the architecture at all. So whatever we discussed earlier, it's the same one. Okay. The only components we did not talk about is Hue and Ambari because those are not really part of Hadoop. Okay. I'll think over, if we could build our own CloudX Lab architecture, or a better idea would be that if you have built a mental map, then you put down that mental map and I could correct if it's right. Okay, great. All right, just give me a kind of rough. I would actually, I'm also thinking about it, that maybe that's required, but I'm not able to, concretize my ideas yet. All right. A common question is, do we build yarn application? The quick answer is hardly. Okay. First, we try to use existing framework. Most of our work can be done via MapReduce, Spark, etc. Second, try to utilize the tools to build jobs, existing tools, okay, such as Apache Slider, Twill, and these tools make it very much possible to to basically run things inside yarn. See, for example, Apache Slider, it runs existing applications such as HBase, while Apache Twill provides you a Java runnable, meaning you can implement an interface and run it inside the yarn. Okay. Still, if that is not sufficient for you, okay, keep in mind that building from scratch could be complex. Okay. So still, after all these warnings, still you want to go ahead and build your own yarn application, I would strongly suggest to take a look at yarn project's bundled example called distributed shell. Okay. That contains the code of how to sample code of how to build a distributed application. All right. This is another diagram. This is not really needed. All right. So that's pretty much about yarn that we wanted to discuss. All right. All right. So that's pretty much about yarn. Okay. A question from RS. Can you have a session on building a Hadoop ecosystem and the components to be downloaded if you want to create your Hadoop ecosystem on your own machine? Okay. I'll give you a quick tip. Okay. So in the session one, I had put some guidelines there that could help you. Okay. Even this installation instruction, okay, it contains a way to set up your own virtual machine. Okay. If you really want to do that. All right. This one is the document that contains how to set up virtual machine. This is the model that we are using to install via Ambari to set up the entire system. Okay. And that should be, if you just go through it, that should be sufficient. Okay. We are also following the same process. All right. And yeah, I'll think about it if it is possible for us to, give a installation or kind of the administration kind of training, but we haven't been able to do it yet. Right. Those are available in the drive that we have shared. Okay, so if you go into the drive, this is the recording folder. Okay, so it has all the recordings of this batch, and those recordings contain the entire detailed data. So this one contains all the detailed data. Okay, so you can take a look. All right, here. All right, you can have the chat.txt. All right. So before it gets deleted, I just upload it there in the Google Drive. Good. All right. The only thing I'm, delaying is in updating these notes. I'll update the notes as well. Yes. So these are the instructions that you would use. Not on, yeah. If you are trying to build on AWS, then these instructions could be useful. We built our own. The CloudX Lab is running on AWS, and we used the second link. Okay, we used the second link. All right. Here is the link to the drive. All right. Yeah, we have the chat logs of past sessions in the same place. All right. Good. Should we move ahead, or is there any question that I missed? Yes, yarn components are installed on CloudX Lab. Yes. So process ID, no, because I'm logged in on E, right? I'm logged in on this particular machine. But if you see CloudX Lab, and inside my lab, it shows the IP address, as well as if you go to Ambari, it'll show you the IP address of the machine on which, say, resource manager is running. Okay, so you can only see the process ID of this machine. Okay, see only the processes that are running on this machine called E. Okay, but not on the process ID of other machines. Okay, a question from Kerr: how long we can refer to the recording sessions? Uh, as long as I don't go bankrupt. Okay, so I'm trying to keep these forever, and I'll try to stick to that. But if you want to keep a copy, feel free to download and copy. Okay, it doesn't matter. And so we are quite open to letting people download. The only problem with the YouTube is that we are not able to allow download, but you can use these YouTube downloaders. With that, you can download the videos. All right, so feel free to keep a copy with you in case you have that. All right, so as long as the company runs, we are going to keep the sessions. All right, so yes. All right, I don't know what is wrong with it. All right, let's move on. Okay, so in Ambari, you can see the yarn. Okay, you can see the yarn. There is resource manager, which has been started. If you click on resource manager, you see it is running on 173.31.53.48. Okay, which is different from this IP address. All right, and if you take a look at node managers, there are these many node managers running right now. So let's take a look at the 607179, this one, right? 6172. Looks like this one, the data node and other things are dead. So let me try to restart things. Okay. So it says node manager is dead. Let me start all the components. and starting these components. Okay, all right, good. So you can see that on, you can actually see it host wise as well. If you click on host, these are the various hosts, and this is my e dot this. Not really, Ravi, because the system was read only. We could not modify any of that. So it's not that reason. Probably one of my guys is parallelly trying to do something to fix a few other things. That could have been one reason. Okay. All right. So node manager is up, and that's good. All right. Now let's start our very important discussion. This I would like to, it's a something which was never a part, but we always wanted to, explain what does it mean. So I would like to start our zookeeper discussion. Okay, it's a very important part of the ecosystem. All right. So let's talk about what is race condition. Okay, what does it mean by race condition? How many of you are aware of race condition? Yes? All right. So, okay, I'll explain what does it mean by race condition. Okay, think about this particular bank. It's a pretty clumsy bank, and it's not really nice. If you see, the there were 17 rupees in the bank. Person A, person B, both tried to deposit 1 rupee or one more coin. Okay, we try to deposit one more dollar into this bank containing $17, and then what you see is person B and person A both read it as 17. Okay, when I say person A or person B, it's maybe the ATM that's doing this magic, and then increased by $1. And at the end of both of this, the overall amount was 18, not 19. Yes. It's also called transaction integrities. Thank you, Ravi. In case of the databases. Okay. This is also known as race condition. Two processes trying to race with each other in accessing certain resource and updating certain resource, causing the corruption of the data. Make sense to all of you? And trust me, since I have worked a lot on the security aspect, secure programming, handling race conditions in your code are probably toughest. So a race condition is a circumstance when two processes try to compete with each other, okay, compete with each other and to access a certain resource, which ends up corrupting data. There should have been 19 if there was no corruption. Yes, that's correct, Krishna. Okay. So this is just one example where it's the same content. So imagine person B was trying to decrease it by 1 and person A was trying to increase it by 1. Okay. So whosoever comes first, comes last would be the item. it has overwritten the change of person B. You see that? It has overwritten, person A has overwritten the change of person B. And these kind of issues are very hard to handle in computing. All right? Is it clear to everyone now? What does it mean by race condition? A and B both were trying to deposit $1, and they, because of their processing mistake, one transaction overwritten the other, and we got the data corruption. What is the deadlock? Yes, we talked about one of the very hard problems called race condition. The other hard problem is a deadlock in computing. What does it mean by deadlock? These two diagrams show you the deadlock. In the first one, first car is waiting for second, second waiting for third, third waiting for fourth, fourth waiting for the first, and so on. This is a deadlock. Similarly, in this another diagram, process 1 waiting for process 2 to finish, process 2 waiting for process 3 to finish, and process 3 waiting for process 1 to finish. And that's a circular dependency. So they will keep on waiting for each other forever and will never finish. This is deadlock. Okay? Yes, deadlock is good. Okay, so deadlock is not really good. Deadlock is a dangerous thing. And I remember in one of the cases, we had a deadlock in program and we did not realize it unless it went to the production. Why? Because in the production, we got concurrent users, and because of which the deadlock started. And because of this, the whole process hanged and nobody had a clue what's happening. And this was a very, very dangerous thing. Okay, it was a very dangerous thing. All right, so we learned two parts. One is race condition and deadlock. Why? Because it's needed here, needed to understand zookeeper. Uh, Question from Sudhakar is which one win, A or B, on the prior example to get 18? Okay, so it's arbitrary here. Whosoever wins, the idea I'm trying to demonstrate here is whosoever win will get the second one. Okay, get the output. Okay, whether A or B. If A came last, A will get A will rewrite the data. If B came last, B will rewrite data. Think of A and B doing multiple operations, and imagine instead of A B there is A B C D E F G doing multiple such kind of operation. The end result will be entirely unpredictable because the end result is dictated by which process finished first, or uh, uh, which combination of processes finished first. Therefore, the results will be unpredictable, totally unpredictable. Okay. All right. Now, the third question that I want to ask you is, how would email processors avoid reading the same emails in such kind of scenario? Okay, so this is something I built earlier, and I would, you know, uh, I, this is a good example of coordination. So it's a usual mechanism where there is an inbox. Let's say it's a emailing list. People are emailing to it. and all these emails need to be indexed. What is indexing? Indexing is a process of taking out the keyword and building an index such that when somebody searches for keyword, it's very easy and quick to locate the emails that contain those keywords. Okay, so it helps the people to search. So there are these email processors that are going to process emails and create indexes out of it. Okay, so there are this inbox, very nice inbox, which receives emails from thousands of users. And this inbox, we need to index every email so that we can search it quickly. Okay, now, question is, if these email processors cannot modify inbox, and every email is identifiable by an ID, a unique ID, then how would you make sure that these email processors can will not process one email at the same time, as well as these email processors will not try to process one email, uh, I mean, will not skip an email. Okay, so no email gets indexed twice and no email gets skipped. And this inbox, the only thing maybe they can do is mark an email read or unread. Okay, so that these only new emails are processed. Okay, so how would we make sure that these email processors do not conflict with each other? Yes. Did I make the question clear to you? It's a bigger question, and these are design questions. In an interview when go for the third round or fourth round, people ask these kind of questions in the design rounds. Okay. Yes. So how will these email processors coordinate with each other so that no email get processed twice and no email gets skipped? Okay, so there's an email inbox. All right, these email processors go and connect to the inbox, read the email, and try to process it. What's the guarantee that if an email is being processed, the other processor will not connect to it? These email processors are running on different machines. So question to you is, how would you avoid it? Yes? April, George, Jiankun, Kar, Karishma, Krishna, Manu, Mohit, Mohsin, Nani, Mitesh, Prasun, Ravi, Sahida, Shamit, Alvin, Hung, Mahmood, Pradeep, Rahela, Srini, RS, Tegu. Correct. There is an intimate processor which defines a mechanism to coordinate. Coordinates effort by Q. Okay. Okay. So, all right. Krishna's question is, if we coordinate effort using a queue, then the problem with queue would be that that they won't be able to do it parallelly. Okay. Srini's point is read all emails in order and have an indicator to make sure it won't get read more than once. But you can have only one indicator on inbox called unread or read. Okay. Okay. So here we are not talking about any kind of ad or something. It doesn't matter to our processors whether it's when I say index, it means taking out keywords from it, and we want to do certain analysis, not classification. We want to do certain analysis um, of every email. Question from Sunesh is there should be some ID associated with each email processor when it's read. Yes, every email has got an ID. Okay. Josh says alphabetize the servers. Okay, let me think. So you mean to say that all the subject lines starting with A should be read by first email processor. All the subject lines starting with, say, B to F should be read by email processor second. That's a good idea actually, if that's what you're meaning. Okay, that's a good idea. All right, that's a good way to coordinate. But the thing would be that if so, we'll have to figure out a way to, do the, how should I say, uh, do it round robin uniformly. Because if, let's say, all the emails is starting with T, okay, or RE, reply, then one of the email processor will get too much busy. Okay. The other logic is that we'll have to identify each email processor uniquely, and this logic would be containing that hard coding saying for this email processor this should be the behavior, for this email processor this should be behavior. Okay. Sunny's point is like ACID in databases or synchronized in Java. So here should be good point. Sunny is saying that what if we utilize the synchronized keyword of Java? That is great as long as email processors are running inside separate threads. Okay, if they are running on separate machines, the synchronized keyword will not help us. If these processors are not the threads, right? This is exactly where the constructs of we learned as a computing, we learned that if we have to coordinate between multiple resources, we'll use the synchronized thread. But in case of distributed computing, that's not useful, because in case of distributed computing, your programs will be running parallelly on many machines. Therefore, that synchronization will not work. Hank's question is, I would think that all the emails are sent to each of the email processors. Okay. Okay. Mahmood is saying that each email processor needs to get a lock before it can start reading an email. But there is no locking provided by this inbox. All right, good. Can yarn be used for this? Um, we can use the yarn for this, yes, but again, coordination would be required there also. Okay, coordination will be required there also. And that's where Zookeeper comes into play. So there are many processes, whether running on yarn or outside the yarn, they might require coordination. And this is where the Zookeeper comes into play. So you see that um, if inbox is not providing us the constructs to create logs, we could use a third-party database kind of place where email, all of these email processors are maintaining the list of things that they are doing. Okay, it's like a huge sales team sitting, and there's a big white board in front of all of them, and whosoever wants to call a particular person, they go there, they go out to the whiteboard and write the name of the customer they are going to call, so that other people do not call the same person. Okay, so in the same way, these email processors are writing the name of the email ID into this whiteboard, this central system, so that other processors do not touch that particular email. Before going to process an email, it checks whether somebody is processing it or not. If not, then write its name and then goes and checks it. Okay? So this is coordination. This whiteboard here, this central system is why is is helping us in coordination. Did I make sense to you? So we basically, instead of trying to hold the lock on inbox, what we are doing is, because we want to coordinate so that not two processors try to read the same email. Okay, so what we do is, since email, as I told you, has a unique ID, as email has a unique ID, we write this unique ID on a central system. So every email processor goes to the inbox, picks up the IDs which are available, and then if those IDs are not being processed by somebody, only then it'll go and process those and mark here that, hey, these are the IDs I'm processing, so don't touch it. So that logic remains uniform in all the email processors, that before processing an email, check with this whiteboard, and only then you go ahead and go ahead and process those emails. Make sense? Rahila, did I make sense to you? A question from George. What about a batch process to each servers? Yes. So batch processes can also mark their, uh, mark their attendance into a similar system. Yes. So I'm keeping that in mind, Yahoo or Gmail. So inboxes, I'm talking about POP3, and POP3 only allows you to mark an email read or unread. It does not allow you to take a lock. Okay. So Sudhakar's point is, if the request is already been assigned to a processor, why would another one look for the same request? Okay. The problem is there is nobody who has assigned the request. There's no central agency which is dividing this work. Okay. Either there could be one idea that we design a central agency. What it does is it basically reads the entire inbox and keeps on sending notifications to email processors, as somebody has already seen, and and then the work gets divided. Instead, there could have been other simple, very simple way that we all will follow this logic. We are, nobody is a master or slave. We will all follow this simple logic, that we will first check on this whiteboard. If nobody is processing a particular email, then we write our name against that email ID, and then we go and start processing that one. Otherwise, we pick up another email. Okay, this is where Zookeeper comes handy. Yes. Did it make sense to you, Sudhakar? You guys have a very good questions, and these questions are very important. And okay. Okay, I'm seeing web email at least as two parts, login and stay connected. So we are staying connected. So email processors, we are assuming that they are connected, all of them to the inbox. Second, send and receive email process. We are not sending or receiving. We are just reading, which are the emails which are coming to the inbox. Okay, all right. Good. So this is called coordination. This is a very good example of coordination. Okay, saying coordination is easier, but understanding the coordination, as we have taken an example. So as Sudhakar was suggesting that if we could, delegate the work, if you could say that these emails are assigned to this particular processor, these emails are assigned to that particular processor, that could have been easier, right? That could have been easier. But for that, we'll have to design a central system. And that central system need to be will suffer from the problems of any single system. Like if that one shuts down, then there will be no indexing, right? So therefore, designing a system could be such as, like, this one is a federated system. Each the same logic runs on many machines doing the same thing, and they follow the same simple thumb rule that pick up few emails from the inbox, check against the whiteboard, and if it's not being processed, write your name and the ID which you are going to process on the whiteboard and start processing. Okay, so that logic is symmetric and same in all the processors, right? Building such kind of system is very easy, provided this whiteboard is really robust, is robust such that it does not suffer from race conditions. It does not suffer from deadlocks. What if one email processor is waiting for other email processor to finish writing on this whiteboard, and so on? There is a circular dependency. Similarly, what if one email processor finished writing and another one has also overwritten it, and both of them started working? And this whiteboard should not have those kind of bugs. This whiteboard on which people are writing, it should not have, it should have those neither deadlock nor race conditions. Okay, did I make sense? It's a very interesting part. So it's a part of the computing, and I learned it hard way, uh, to how to make coordination. And all right, and as we go ahead, we will see many other example. Although theoretically people talk about various kinds of philosophies, but in reality we need to know these few things. Right. All right. So basically, every email processor, every email processor, every email processor is writing their name against an email ID so that the other one does not read it. Okay, and that's being done using the central system. Okay, so what is Zookeeper? Zookeeper is that whiteboard which is a distributed coordination service, a whiteboard which is under the hood running on many machines. This whiteboard that I told you looks very neat and simple example, but under the hood it's running on many machines because it has to give you this kind of reliability. Okay, it exposes a simple set of primitives. it exposes a simple set of primitives and is very easy to program to, uses a data model. Now you might ask, like, do I need to draw on this whiteboard, or is it like a database table, or is it like a folder structure? It is like a folder structure, okay, in which you write something. It is used for synchronization and configuration management. It does not suffer from race conditions and deadlocks, okay. So the data model is something which we need to learn before we jump into anything in case of Zookeeper. A Z node is the entity in which Z node is not like physical machine. It's like a folder. It's like a database record. Okay, Z node is like a database record or like a folder in which we put the data, in which we stuff our data. So Z node can have data. Just like we say, my folder had some data or my file has some data. Similarly, Z node in case of Zookeeper has some data. Okay, in this Z node, we can only set the data. There is no update, no append. Sorry, there is no append or there is no partial writing. There's like we completely change the data. We don't partially change the data. Okay. Modification, the data access is either full or nothing. Okay. There is no midway. There is no midway. There is no dirty. There is no half written or nothing. You always think of this data model like a highly available file system. Okay. Because the folder structure is exactly represented the way Z nodes are. A Z node contains data, and Z node can have another Z node, and so on. For example, in this diagram on the right hand side, what you see is slash is the top level Z node. Okay, this is already created in in the Zookeeper. Okay, so you can always think of Zookeeper like a central place where you store data in the form of this. Okay, in the form of this. So slash is the top level Z node. Under slash, we have created a Z node called zoo. Okay, the zoo would contain some data. Under zoo, we have created further places where we could store data. Duck, goat, and cow are Z nodes, which are children of zoo. Okay, so it's like an inverted kind of tree. Is it clear? Not clear? I hope we have not discussed Zookeeper yet, right? We create this data. This is for us. Okay. Other systems also use this data model, and we either our programs or we ourselves can use it. This is how we store data. Zookeeper does not process this data. We will see more example now as we go ahead. So for you, in case of in our case, we don't have to set up Zookeeper as such. We can simply start Zookeeper by saying Zookeeper client. Okay? Yes? Okay, so this is Zookeeper console. Nitesh's question is what we normally keep in this data model. We keep a small amount of data needed for coordination, as we told earlier in the case of our email processors trying to coordinate is the email ID that was there. Okay, email IDs that will be kept along with the each processor's ID. So it's small tidbits of information that we keep there. Right now we're connected to Zookeeper. Okay, again, to get started with Zookeeper, we are going to use this client called Zookeeper client. Okay. Here, we can use ls command to see what's there. ls slash, meaning show me all the nodes under slash. So these are the nodes under slash. Okay. These are the nodes under slash. You see that? Schema, registry, Prezi, sub, this. So these are the nodes created by other students. All right. Good. To see what's there inside a particular Z node, let's say we pick up this particular example of 27th August. We say get slash 27 August. It shows that this is the data that is stored in this particular Z node. Okay? Yes? All right. Let's try to create a Z node for this class, and we are going to call it 14 Gen. Okay? And we are going to say class for, actually this data has to be JSON formatted. Okay? So class for 14 Gen. Okay? And we always specify, okay, specify the complete URL. Here slash means the top level Z node. Okay? Top level G node. We can actually see what is there in the slash. It's empty, right? So we use ls space slash get slash say 14 Jan, and we also created this one. Okay, you don't have to create, because if you try to create, it'll give an error. Okay, sorry, not this way. So the last command was wrong. Okay. So we use this command to create Znode. Okay. So now you can use Zookeeper Desk client to start. All right. Now all of you create your own Znode under 14 Gen. So I'm going to write my designation. Okay. Or in this, I'm going to write something um, like my location, okay, in the data. Now it's created. So you can write your Z node in your own way, okay? So I have written Sandeep Giri, you can write something else. So we are creating this Z node with this data, okay? Let me check if it is containing the data. Yes, it contains my data. Let me check if anybody else has created. Okay, so I can see Srini has created. Good. Who else has created? Quickly. Okay, Zian Kun has done. Good. Sunny has done. So see, we are able to coordinate clearly, right? Between amongst ourselves, right? So if I create a particular record, you won't be able to create the same one, right? So these are like, we all are like email processors, and we are trying to coordinate amongst each other. So please create our own Z nodes, okay, using first, okay, first, okay, launch Zookeeper using Zookeeper Desk Client, and then create your Z node under slash 14 Gen, okay. Let me see who has done. Okay, okay. All right, I'm just going through the list. Nice. Nice. Now you can see clearly that I would know if one of you did not do create the Z node. That's the power of coordination, right? Zookeeper dash client. Are you in the Zookeeper? All right. So, okay, I can't see Rahila's one. Okay, so I'll put the commands properly. So first you launch Zookeeper dash client, and then you create your own Z node under 14 gen. This is the command that I use to create Sandeep Giri under 14 gen. And this is the string I gave. This is the data I wanted to give. If you leave space here, it'll give an error. Why? Because you have to put it something like this then, right? Okay. All right. Okay, let me see. All right. So how many are done? Including myself, it should be 29. Okay. How many are there? Actually, I can do a word count and that should be good, right? I can do WC. So only 14 have done yet. Good. One more. Yes. Keep going, please. Yes. Yes. Okay. So I can actually do the word count and it should tell me, right? Okay. Let me do the word count again. 16 only. Okay. Good. Good. Keep going. Yes. One more. All right. Is anybody stuck? All right. George, you can take the screen. Let me stop sharing and then, yes, now you can, I can take the screen. I can't see ERP. No, I can't see ERP. I can see Ravi. Okay. Zookeeper. Oh, it has to be client, not client. And there has to be, yes, go up arrow key, press up arrow key. Your command was right, just that there was space between Zookeeper and client. Yes, this is right one. Enter. No, there is a space between Zookeeper and dash client. Remove that space, go up and arrow key. Yeah, that's it. Remove that, yes. You can also check by saying the same command, ls space slash fucking gen. Okay, 4 JAN, 14 JAN. Yeah, enter. You can see these are the nodes created. And all right, now you can say create and use the command which I have given you, okay, to create. All right, I think the rest you can take forward. All right, yes, great, George. All right, yes, Rahila, you can take the screen now. I have, yeah. Okay. Kar, can you give your login password to me privately? Okay. So here you can write ls. Wait. I'll tell you what. Okay. So ls is good. Now you create it. So when you said create, right, there was a space between slash and that. That's the error. Okay. So say create space, write the URL. Actually, you forgot to provide the data to be set. Create space 14gen ERP, create slash 14gen slash ERP slash space. Just double quotes and say data. This is some random data. Okay. Enter. That's it. Okay. Now let me check if I can see. Okay. What happened to my? Yes. You can see. Yes. Now it's good. All right. Is anybody else stuck? Okay. So yes, a problem from Kar. Okay. So Kar, do you get which one do you get? The uh, what's your? Let me log in into lab and then fix it. Okay. And yes. So we have enrollments. Okay. So which console is yours? E, F, G, H? F. Okay. SSH. Then this at f.cloudxlab. Okay. I keep logging in correctly. This is okay, Kar. I think it's probably the copy pasting thing which is giving you trouble. Okay. It is only copy pasting thing that's giving you trouble. If you go to here, f.cloudxlab. Okay. Yes, I'm able to log in. Okay. So question from Mahmood is how to bring, just click on the console. Okay. Click on web console. There'll be a link and that should be good. Okay. So next to Ambari, there'll be a link for Hue and next to that, there'll be a console. Click on the console and that should be okay. I got the, okay. Yeah. Show me the screen, please. Let me stop sharing. All right. Is anybody else stuck? So that's pretty much for today. And those who are not who are stuck, please stay back in the session. Those who are done, they can leave and have a great week ahead. I look forward to see you in the next session, and would love to have more questions. Okay. Okay. Just a second. Mahmood, give me 2 minutes. It's okay. It's okay, Mahmood. If it's giving that error, you just press Y and it should be good. Okay. Yes. Yes, I'm in better health now. Thank you, Ravi. Yes. Those who are stuck, stay back, please. I'll fix other things. Okay. All right, great. So let me see how many of us are able to. Yes. Okay. So who? Okay. Krishna. Yes. Start the zookeeper, please. All right. Okay. Go ahead. 14 Jan. Yeah. Not Jan 14. 14 Jan. Yeah. Good. Now say ls space /14 Jan. Enter. Good. So it's working fine. Awesome. Awesome. All right. Yes. So, all right. Now, who is next? Mahmood and Krish. Okay. Okay. I see. I see. Yeah. So a BLR is just another data, Pradeep. It's basically is some data. This is the data, and we are specifying that create a node for us, create a Z node for us, and with this particular data, BLR is the purpose why we are creating the Z node. Okay, it could be any data. Yeah, just put my Bangalore location. That's all. Okay, so just that data that I want to keep inside that node. Okay, good, good. There was a few more person. Mahmood, are you able to connect? Ah, I see. So Manu, what you have done is because you have not provided slash between the two, so your G node will be created at the top level with the name 14 Jan 2017. Let me check. Let me check if it is created. Okay, so what I see here is 5. Where is my G node? 14 Jan is here. Okay. And yes, any other Zeno do we see here? All right, good. So done. Let me check who else has done. 14 Jan. Okay, good. Now I think quite a few of us have already done it. Yes, it does not accept the spaces between that. Yes. So what you have to do is you have to put double quotes. Within double quotes, you put single quotes, and then you can put it. Okay, because it's expecting a JSON object within the double quotes. Okay, all right. So there are few more persons who are stuck. I think 3 more people. Not 3 more people. Yeah, 3 more people. No. Mm, yeah, 3 more people who are stuck. Okay. So Mahmood, can I make you the presenter, or you can just share your screen, and that should be good. I could help you out if you are stuck. It's interesting to know that you have SSH installed on your Windows machine. Have you installed Sigwin or something? All right. Good night, Kar. I look forward to see you next time. And all right. Okay. Okay, so you are logged in here. Good. Press enter. Why don't I see the press? Yeah, say ls space slash 14 gen. Good. Enter. All right, now you can create your own. Create space slash 14 gen slash whatever Z node you want to put space. No, you have to provide, yeah, data also, some data. Yeah, enter. Yes, it is created. Now check it. ls space slash 14. Good, good, awesome. All right, so it is created. Let me check. Where is it? Why can't I find it? Yeah, it's there. Yes, thank you. Good. So this is
Did install Cygwin.
what?
Don't get. I did. You asked me if I had installed Cygwin. Yes, I did install Cygwin.
Okay, okay. All right, that's nice. All right. I was wondering like how come you have SSH on Windows? So that's
Yeah, but still, I wasn't able to connect from there.
okay. Can I take a look, please?
Yeah, I will just bring my console.
Yeah, that's the one. So not A, you have to use E or F or G. What was
Oh,
the URL you have in your console? E. You are on E, so use E and he'll work.
oh,
Okay.
this. Oh,
Instead of A, you say E.cloudxlab. That's it. You. Yes.
okay.
And paste the data, paste your password, and you should be able to log in. Wonderful. That's a new thing I came to know that it would work that way.
Maybe I don't have it.
All right. Okay, yes, that's the one.
Okay. Yeah.
Great, great.
Nice.
All right.
Yeah.
It's wonderful to have all of you in the class, and I look forward to have more good questions from you. And great. All right. So thank you, everyone, and I look forward to see you all in the next session. Okay, is there anybody who is left and who is stuck, who needs help? Okay, Srinivira, can I make you the presenter? All right. Yes. All right. So let's try to open the console. All right, let's log in into LMS. Open the browser.
Hello, Sandeep. I'm not able to log in like my account or Sandeep.
Okay, okay. So let's try to fix that right away. Okay.
Yeah, but I'm not able to see the screen like. But I share my screen. But what I can.
I can see your screen.
But I'm not able to see.
Oh, okay.
Don't
So,
share my.
at this point, it's only one of us can see the screen. Okay. So can you open a browser?
A browser. Okay.
Yeah.
Yeah.
And go to nobigdata.com. Okay. Did you receive an email which we had sent you?
Yeah.
Okay. So log in into this.
Yeah, I did it. I don't know, like sometimes we are able to log in or sometimes not able to log in.
Okay, no worries, no worries. Let's. Oh, wait. Yeah, I have sent you an email before the session saying use M here. Actually, it's my mistake that I modified your email, corrected it to .com instead of M. So that's why I had explicitly sent you an email. I think
Oh, okay, okay.
I'm extremely sorry for
Oh,
that.
I didn't get the email, Sandeep.
Okay. Oh. I actually responded to the previous email. Okay. Just save it and yeah. Let's yeah. Now go to my courses.
Yeah, that maybe due to that one, I think you change it. I didn't
Yes.
get that update. Maybe that due to that one, I think.
Right. So one more question I had for you is, did you keep some data in CloudX Lab? Because your account will be newly created now.
Oh yeah, yesterday I done some Unix. Whatever the session you given that 87 pages, I done like 30 pages.
Wow. Okay. So yes, I what I'll do is I'll give you the account for the previous login as well. So you
Okay.
have actually two accounts now. I'm extremely
Yeah.
sorry for this.
Yeah, if you don't mind, like
Yeah.
Sandeep, like can you create like account? Don't put the full name, like full name and last name. Can you
Okay.
make it like short and can you do it something like the Srini
Uh,
Veera, something like that?
no, actually, that's the challenge I have. Okay.
Okay,
Yeah, and because this entire thing is automated, so if we change the email ID, the account also gets created automatically. Okay.
okay.
Just give me one more second. Actually, you had done the entire work yesterday, and wow. So let me try to change this. Okay. Let me try to change.
Nothing also, but can you put it like instead of like that blue sheet, like you can put the personal email stream on 99.99. Why I'm telling, I
Yeah,
can't
yeah.
go, suppose anything like I can't go to office mail and I can't check it like every time.
Uh, okay. I see.
This I'm doing like my personal laptop and that's why.
No, I'll tell you something. Okay, okay. Yeah. I can change. You can give me your new email ID. Okay.
Yeah,
I will update that one and use that one. Okay, everywhere.
sure. I can email it to Sandeep.
Yeah. And I
Thank you
will
so much.
also.
It's really great.
Okay. So what I'll try to do is first. This is your right. Rest, I think you will take care of everything, right? Whatever we have
Yeah,
done.
yeah.
Okay.
Yeah, but right now, like, yeah, now I can try like maybe that GQ per client. I'll try maybe if I stuck, I'll get back to you.
Okay. Just a
Well,
second.
initially, but my logging, I'm unable to log in the account. That's the main problem.
I'm really sorry for this, and it's my bad. So anyway, you have your old account as well here. I'll show you Srinivas. Okay, there are two accounts actually here. You see, Srinivas Veera. This and this are your two accounts actually. Okay, and I
Unable to see your screen.
okay.
Okay.
And never mind. It's good that you are not able to see because all the password was showing. Okay, and yes, all right. So yeah, I think I'll resolve these matters maybe today, and we'll do it.
And one more question, Sandeep. Like when I'm chatting, like are you able to see my name, but never address your my name? Like just your everyone name. Mostly, I'm hearing like you
Okay.
never
No.
address my name.
Yeah. So yeah, that's what I'm also wondering.
I don't know. I'm able to see when I'm
Yeah.
shorting me
Yeah.
only, but you are not addressing. But means
Just,
are you able to see or not? I have still doubt about it.
just give me a second. So actually, Srini, did you join later?
No, but that actually I enrolled it last batch,
Okay.
but due
Okay.
to holidays I postponed to this batch.
Okay. No, I'm able to see. I'm able to see your name. I'm able
But
to.
I'm not able to see, and I never addressed like Srini Veera or
Uh,
something. One more Srini also there, like, but I'm confused always.
no, actually, I always say one name, and that's the reason. Okay. And I always say Srini. So either you
Yeah,
or
but no, I didn't hear Srini also like
okay,
just you are addressing without addressing you are like
okay.
answering the questions always.
No, I can see your now. I can see your question, but you have asked after around 10:30 only.
Yeah, yeah, yeah.
Okay, okay, that's the reason. So after 10:30, I've not addressed people personally, and yes, so I can see. Don't no worries. I can see your questions. Okay,
Okay.
okay,
Just I'm starting, but I didn't have much knowledge about like big data. I have
okay.
like ETL knowledge, but I don't know like how much I can pick up and
No worries, no worries. Okay. No, so you do one thing. Please do me a favor. Just drop me an email at support at no big data. Support at no big data, asking to change your email ID. Okay, I'll fix this thing because it's going to be a little messy. Okay.
sure. Thank you, Sandeep.
All
But
right.
I'll try to that to create like Jupyter. But if I don't create, I'll get back maybe
Oh,
next class or in middle
yeah.
or sometime.
Yeah. So
Okay.
yeah. So do one thing. So just make sure that you drop me an email, please, because I'll forget after this session. The problem is.
Yeah.
Okay.
Thank you so much,
All
Sandeep, and good night. Thank you so much for our help.
all right. Thank you. Thank you, Shini. All right. Is anybody stuck? You need my help? Tegu and Shamit, Ravi, Mohit, and Kar. Great, great. All right, let me just check. Okay, so looks like everyone is through with it. Wonderful. All right, so who are the two people who are left? Okay, one would be Srini, and who else? Okay, is it me? All right, wonderful. And Kar, do you need any help from my side? All right, great. Mohit, all right. Are you around, Mohit? I think Mohit has gone to sleep. All right, look forward to see you, and I look forward to see your questions at support at no big data. Okay, support at no big data, and thank you very much. All right, bye bye. Have a great week ahead.